Okay, so our topic for today is all about machine learning. So I think I'm very sure that all of you already know machine learning. I I mean at this point in time, you already know what machine learning is all about, but let me just give you a very brief introduction that will be related to data science. Okay? So your machine learning is basically from, if we're going to take a look into the AI perspective, okay, so if it's based on artificial intelligence perspective, it's actually learning based on how human actually perceive things. No? Okay, so learning is central to human knowledge and intelligence, and likewise, it is also essential for building intelligent machines. So it's like making your machine think like a human being. Okay, now from software engineering perspective, it allows us to program computers by example, no, in which it can be easier than writing a code or even following a very traditional way of creating, no, a certain program. Okay. Now, if we're going to take a look into a statistic perspective, no, it is actually a marriage of computer science and statistics itself. No, so it's like a bumped up, no, bumped up statistics because your statistics is actually combined with computer science. No, how you code, okay, and then algorithms, etc. No? Now, computational techniques are also applied to statistical problems. Okay. Now, from a broader perspective, no, it's a set of tools that allows us to teach computers how to perform tasks by providing examples of how they should be done. Okay, so basically that's your machine learning. Okay, and there are phases of machine learning. Okay, so number one, you have your training, and then number two, you have your application. So for the training, I think you already know this one. No? In order for a certain model to be able to learn something, you have to train it first. Okay. So a model is learned from a collection of a training data. Okay. And then, of course, no, the training data would come from an environment, okay, in which, say, for example, based on the scenario that you want to train that specific, no, or that particular model. Say, for example, if you want to detect people crossing the street, no, so meaning you have to collect data from a street scene, okay, and then where people actually passes by or crosses the street, and then from there you capture that scene, whether it's video or an image or whatever, no, and then from there you input that to your model so that you would be able it would be able to train and learn something, no, out of those data set, no. And then the next one is, of course, your application. The application is where the model is used to make decisions about some new test data. Okay. So here, after you have trained the data, that train the model, okay, rather, what you're going to do is you're going to introduce, there are certain ways, no? You're going to introduce a new data set. You call this test data set. No? And then from there, you will measure, no, if your model has really, no, has really recognized people, okay, that actually crosses the street. Okay, so normally when you capture data, you actually split them into two. Okay, there are cases where you split them into three. No? It depends on the requirement of the project. No, but in many cases, you actually split your data into two. Okay, I think you already know this one, no? From your basic data science. No? It's either 70 or 30. 70 for that will serve as your training data, and then the remainder will be your test data set. Okay. Now, there are also several types of machine learning. Okay, so the first one is your supervised learning. Now, the supervised learning is actually an approach, okay, to create, or in terms of creating an AI where a specific or probably a combination of computer algorithms is trained on the input data that has been labeled for a particular output. Okay, so here the training data set is labeled, okay, with the correct answers, whether it's good or bad. So it depends on 1 or 0, yes or no. Okay, and then the two most common types of your supervised learning are as follows. No, the first one is your classification. It's a classification algorithm. Okay, it's a type of supervised learning technique that is used to identify, say, for example, a category of, um, say, newly brought observations, no, on the basis of your training data. Now, in classification, you have to take note that the program learns, no, from the given data set or the observation, and then classifies the new observation into a number of classes or probably groups. Okay. Now, on the other hand, you have your regression, no, where the outputs are real valued. No. So regression is also a supervised machine learning technique in which you use to predict continuous value, okay, or continuous values. No, the ultimate goal, or okay, of the regression algo is to plot the best fit line. Okay, you know naman, no? If we're talking about regression, there's always a line. No, so here you want to plot the best fit line, or probably a curve, no, between the data. Now, there are three main matrices, no, that you can actually use for evaluating and training the regression model. No, you have your variance, you have your bias, and last one, I think you have your error. Okay. Now, the next one is you have your unsupervised. So if you have your supervised learning, you also have your unsupervised learning. So the unsupervised learning is a collection of unlabeled data. Okay, so meaning you just, put all of your data there, unlabeled, unannotated, okay, which we wish to analyze and discover patterns within. No? There are two most important examples. No, the number one, you have your clustering. This is to discover the inherent groupings in the data, such as grouping customers by purchase behavior and so on. No? I think basically you're already familiar with this one. No? This was actually introduced to you during the time that you have taken the introduction to data science. But then again, clustering is a process of, like I've said, a grouping of similar entities together. And then the goal of the unsupervised machine learning technique is to find similarities, okay, in the data point, and group them into similar forms, no? And then all of this one, say for example, you have groupings already, then from there you may be able to find out another data points, no, when they are grouped together or when all of these are actually clustered together. That's why it's called clustering. Okay. Now, for the association is basically to discover rules that describe large portions of data, such as people that buy X also trend to buy Y, and so on. So it's an unsupervised learning. The algorithm tries to learn without a teacher of some sort. No? Parang ganun siya. So learning without a teacher, as the data are not labeled. No? So basically, the rule in terms of association is descriptive, no, not prescriptive in terms of method or methodology. No, so generally it's used to discover interesting relationship hidden, okay, hidden in a large data sets. Okay. Now, the next one is you have your reinforcement learning. Now, reinforcement learning is a machine learning training methodology based on like a rewarding a sort of a good behavior or a desired behaviors, no? And it is also punished, no? Parang you're training a dog, okay? If you've seen a good behavior, you reward your dog. If you have seen a bad behavior or behaviors, you actually punish them, or undesirable behaviors, you actually punish them. No? Okay. So in general, the reinforcement learning agent, okay, is able to perceive and interpret its environment, no? And then able to take actions and learn through trial and error. Okay, I remember one time, I don't know if I mentioned this before. We had this parang ano siya, thesis nga siya, thesis namin siya, and then we have this agent, and then we allow this agent to learn something, no? Ayun nga, parang inano namin siya, play namin siya sa human, and then meron pang isang ano, di ba? Merong isang data set wherein ito yung coming from that particular environment, no? Yung ginamit namin. And then ito yung may mga bots na siya, and then we have our agent, no? So first we train our agent playing with the humans, and then training the agent playing with a bot, parang robot na siya. So it may be able to we want to see if that particular agent, which is the agent we created, would be able to learn something, no, from the humans, and of course dun sa dun sa bot na dinownload namin from that environment, no? Anyway, ayun, okay lang. I think siguro some of you might consider this one, no, as a thesis, no. Parang if you want an agent to learn something, no, parang ganyan. It's very minimal. I have seen thesis topics that is related to reinforcement learning. More on supervised, unsupervised, no, tsaka ano sila, more on NLP, yan. So please, no, if you're going to consider your future, okay, thesis topic, no, might as well do away with yan yung mga NLP na kasi parang medyo, like I've said, no, gamit na siya, no. Okay, so ano na siya, parang ano ba ngayon, 2022, so 2020 pa siya, parang ganun. Okay, so this one, reinforcement learning, I don't know how you're going to I think pwede pa rin siya, reinforcement in terms of image processing, recognition, I don't know, movement of movement of people or whatever, no. But basta I've barely seen reinforcement learning kasi parang medyo ano siya, I don't know, medyo mahirap daw, or I don't know, but something that you can actually consider as your topic. Yun lang. Okay, so saan na tayo? Yeah, so that's reinforcement learning. And then the next one is you have your semi-supervised learning, no? Now, semi-supervised learning is a combination of your supervised and unsupervised machine learning, okay, methodologies, no? And then with more common supervised machine learning methods, you actually train your machine learning, the algorithm per se, no, on a labeled data set in which you record, and then from there you actually test them with an unlabeled data. Okay, so that's why it's semi-structured, no. One good example of a semi-supervised machine learning, no, is merging your clustering, okay, clustering and classification algorithms. Okay, where in your clustering algo are the unsupervised machine learning approach, no, for grouping the data set based on the similarities. And afterwards, no, I don't know, you just use others, no, or you're another algorithm to be able to do the testing. Okay. But basically, only a subset of the training data is actually labeled. And then typically a small amount of labeled data with a large amount of unlabeled data. So it's the other way around. Normally, no, not in you know splitting the data, but more on you label them, no, small amount of labeled data, and then you test them with an unlabeled data. This is something also that you can consider, no, in terms of learning, no? Kasi of course, if you don't have any reference, no, in terms of your testing, that is when you would be able to know that your machine is actually learning. Okay, unlike if your training data is actually labeled, no, you might have some problems there in terms of biases. Okay, you might have an overfitted model because you keep on labeling this data, and then all it knows is that when it sees this particular, particular, I don't know, scenario or particular pattern or whatever, no, it will actually say na, okay, this is the one that I'm looking for. Okay. So there are also some, not really danger, but there's some don'ts, no, in terms of having a huge amount of data with specifically if it's labeled. No? You might get a biased, okay, model, or you might get a overfitted model. No? Okay, overfitted result. Okay, so that is why there are some cases wherein you actually implement a semi-supervised learning. Okay. Now, the next is you have your time series. Okay, your time series forecasting, okay, can be framed as a supervised learning, and then the use of a model to predict future values, no, based on a previously observed values, no. So if we're talking about, we're not just talking about data science here. We're talking about data warehousing, business intelligence, okay? And then there's a lot of time series forecasting that you can actually implement, okay, especially in data warehousing, because you're actually using or utilizing historical data, okay? Like I've mentioned there, no? Supervised learning, and then you may be able to predict the future because this is actually based on the previously observed values, no? And the application of time series models, no, are very, very wide, no, wide ranging, I might say, no. You can actually implement it in sales forecasting, weather forecasting, and so on, no? So basically here, the decisions that involve a factor of uncertainty, okay, because it's a future, no, of course, every future it's uncertain for that matter, no. Then time series models, no, have been found out, okay, to be among the most effective, okay, effective methodology for forecasting. All right. Now, also time series forecasting, no, or forecasts inform all kinds of business decisions, no, strategic decision making, okay, and all of those, no, related to your, not just your data science, but also your data warehousing, business intelligence, business analytics, and so on. Okay. Now, there are several forecasting applications, no. So say for example, forecasting power demand, no. Say for example, in Luzon grid, Visayas grid, no, Mindanao grid, and from there you decide whether you're going to build another power plant, no, in the next succeeding years. Let's say for example, the next 5 years. Also, forecasting call volumes, no? To schedule, say for example, a personnel that would coming in for the next 2 weeks or 3 weeks, diba? Since we are work from home, I think fairly for a call center office, no, or call center firm, I think some of their staff, no, or personnel has been, being, reintroduced, no, in getting into the office, no. So I don't know, probably, no, based on historical data, okay, analysis shows that at this, parang time of the year, okay, or time of the month, there will be volumes of calls for whatever reason, okay, that would be expected, no, and it's best that you require all the call center staff, no, to be present so that they may be able to address, no, problems that would arise, no. Yan. What else? There are also forecasting in terms of inventory, no, inventory requirements, no, so that you may be able to stock up your inventory to be able to meet the demands, no. So, for example, in every summer, I think for cement hollow blocks or lumbers or steel sheets that you use in the roof, no, it's best that you stock up this kind of items in your inventory, because during summer normally people wants to do house repairs because it's summer, or you stock up paints because since it's summer, okay, it's nice to do painting, no, kasi it's summer nga, unlike in terms of say during the rainy season, okay, you actually lower down the stocks of your paints because normally nobody wants to do the painting because of the, I don't know, the rain, and then it messes up things, no? So instead of stocking this item, you might want to consider other items, no, that would be able to give you more profit, no, rather than stocking paints, no. Yeah. So that's forecasting. All right. Yeah. So moving forward, no, these are applications of your ML, no, adaptive websites, no, effective computing, no, yung mga behavior nyo. Yan, baka makakuha kayo rito ng mga ideas nyo, no, in the future. Brain-machine interfaces, cheminformatics, no, classifying DNA sequences. Yung DNA, meron akong classmate sa PhD, yan, mga DNA na wala, hindi niya rin pinursu kasi walang dataset. Tsaka wala siyang makuhang mga expert. Yan. Computational anatomy, and then you also have your computer vision, including object recognition. Ito to, ano to, very, very ano to. Sought after itong mga to. Yan. Detecting credit card fraud, playing game playing, information retrieval, internet fraud detection, yan. Linguistics, marketing, okay, machine learning control, perception, medical diagnosis, economics, NLP, yan, no. NLU. Ito, processing the language. Okay, this one, natural language understanding naman. Kumbaga, medyo higher level na to. To be able to understand language, 'di ba, no? So for example, yung interpreter niyo ng Google Translate, it would be able to translate, no, a natural language, understand it, and translate it into a foreign language. Yan. Optimization and meta-heuristic, online advertising, you have your recommender system, robot locomotion, etc., etc. So ang dami-dami niyan. And more due to the introduction of data science. So given all of this, no, all of these examples of machine learning applications, no, you can actually apply, or you can actually pursue one of this, no, one or couple of this one in terms of a suggestion or probably consideration in terms of your culminating paper, no. And then all of this are actually due to the introduction of your data science, no? And there are also different approaches to machine learning, no? You have your decision tree learning, you have your association rule learning, artificial neural networks, deep learning, inductive logic programming, SVM, or what we call support vector machine, clustering, Bayesian networks, reinforcement learning, representation learning, similarity and metric learning, sparse dictionary learning, genetic algo, rule-based ML, learning classifier system. Okay. And for your DS, no, for your decision tree learning, okay, this will be based on your activity for today. Okay. Now, decision tree learning is the construction of a DT or decision tree from class label training tuples. Okay. So uses a decision tree as your predictive model to go from observation about an item represented in its branches, of course, to conclusions about the item's target value, no, which is represented in the leaves, no. And the goal is to create a model that predicts the value of the target variable based on several input variables. Okay, so here, say for example, you have your weather data. Okay, so I think the decision tree is not new to you anymore. I have introduced you DS and a couple DT. Sorry, I have introduced you decision tree before, and then I think as far as I know, I've set two examples. No, okay, for you to be able to understand. No, so basically, what we're going to do today is we will be creating a decision tree based on a given data set. No? Say, for example, the weather data, okay, play or not to play golf. Okay. Now, here it's mostly the data set that you're going to utilize. No? And then you have a table here. So for example, if the outlook, these are actually your attributes. No? Okay, so you have your attributes there. And then say for example, you want to play golf. If the outlook is sunny, if the temperature is hot, if the humidity is high, and is it windy or not, if it's false, then you don't play golf. Okay. And then if the outlook is sunny, temperature hot, humidity high, windy true, and then still you don't play golf. So these are the data set, no, that you will be considering, no, as an example. Say for example, there's an instance here wherein sunny, temperature is mild, humidity is high, and then windy falls, again, play no. But sunny, temperature is cool, humidity is normal, there's no wind at all, then you can play golf. Okay. So you have attributes that would be able to say whether you can play golf or not. Based on those four attributes, you have the outlook, you have your temperature, humidity, is it windy or not. Okay. So all of this will be shared to you on a particular website. And then there's also a way, wait lang. Okay, so there's also a way to be able to make this work, and then you find solution. Okay, so the first thing is, of course, there are, parang since we're tackling decision trees, no? So if it's outlook, okay, if it's sunny, overcast, and rainy, these are your answers, no? Okay, so yes, yes, no, no, no. And then if it's overcast, no, yes, 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 yes. And then if it's rainy, yes, 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 no, no. If it's humidity, high or normal, yes, 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 no, 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 etc., etc. So this is basically using your intuition or heuristic, no, approach, no. So if heuristics, no, it's something where you use your ML and your AI when the decision is impractical to solve, no, particularly problems with a step-by-step algorithm. So just push it, no. This approach actually would emphasize speed over the accuracy. Okay, or if you want to go with intuition, of course you will be using your machine learning and so on. Okay, like I've said, decision tree to play or not to play your golf. Okay, so if it's the outlook, then you have three: sunny, overcast, and rainy. So basically, if it's sunny, there's another, no, decision tree nga siya. There's another question: is it humid? What's the status, or is it normal or high or whatever? No, if it's humidity we're talking. If it's high, no. If it's normal, still no. If it's outlook and sunny, this is actually based on the table that I've shown you a while ago. Now, if it's the outlook is overcast, then play yes, so on. And then for rainy, windy, yes or no. Either way, no. If it's windy, yes or no. For yes, if it's windy, no, you won't play golf. You cannot play golf. If it's windy, if it's no, then yes. Okay. So this is just an example. No, there are several tiers, no, that you will encounter in terms of the decision tree. No, and then these are some of the well-known decision trees. No, you have your ID tree, okay, iterative, dichotomizer 3, and then you have your C4.5. I think I introduced guys sa inyo yung C5.0, right? Tama, no? Okay. And then C4.5 is a successor of your ID3, no? Yung dichotomizer nyo. And then the C4.5 is yung C5.0 is the successor of your C4.5, no? And then you also have your classification and regression tree, which we call it a CART. And then your chi-squared, automatic interaction detector, okay, yung CHAID. And then yung multivariate adapter regression splines, no? Or splines, no? Or we call it MARS. Okay, ibang MARS yan, ha? MARS, sila MARS. Okay. Now, there are metrics used in decision tree algorithms. No? A decision tree algorithm chooses a variable at each step that best splits the set of items. No? For example, these metrics are as follows. You have your information gain, your gain ratio, and Gini impurity. No? Normally, pagka C5.0, C5.0, ginagamit natin doon is yung entropy. And then pagka CART, ang ginagamit natin doon, Gini. Okay. And then there are also for the computing, no, information or information gain or information is actually measured in bits. No? Given a probability distribution, the information required to predict an event, that is the distribution's entropy. Okay, yung entropy, like I've said, no, entropy gives the information required in bits, and this can involve fractions of bits, no. And then the formula for computing the entropy are as follows, no, or is, no, entropy, okay, open and close parenthesis, no, p sub 1, p sub 2 to p sub n, where that will be equal to negative p sub 1 log p sub 1 minus p sub 2 log p sub 2 and so on. Okay, until no p sub n log p sub n. Okay, now this is also an example of the table that I've mentioned a while ago, no. So this will be your basis as an example, no? And titingnan nyo lang siya, and then you have to, say for example, ng attribute outlook, no? Ang outlook kasi meron siyang yes or no, okay? And then from there, titingnan nyo yung entropy niya, the formula to apply, you will apply the formula. And this is the example. Yan. Yan yung example niya. So here, okay, so for the outlook, no, info 23, kaya siya nag 23, okay, kasi meron siyang instance doon sa table, and then to be able to compute the entropy, okay, kung ilan siya, kung 5 siya, yung instance siya 2/5, tapos 3/5, so this one. And then that will be equal to your -2/5, okay, and then log, okay, multiplied by 2/5 minus 3/5, this one, log 3/5. That would give you 9.71 bits, no? Take note, guys, okay, ito kasi hindi log 2 siya, log sub 2, hindi siya natural log. Okay, tatandaan nyo siya. Ibibigay ko sa inyo yung parang Excel formula na ginawa namin. And then from there, you will be able to understand it clearly, no? Para malaman nyo yung ano niya, yung pinaka how would you be able to get the formula, the result, no? So this one, ang parati nyong gagawin ay to be able to compute this one, ito muna, log, ano to log of 2, okay? Tapos 2/5 siya. So meaning, kung calculator niyo siya, ln siya. So ln, okay. Kasi hindi niyo siya, take note lang pag ika-calculate niyo siya later on, no? Pag itatry niyo. Doon sa Excel, kitang-kita naman. Pag log to the 10 kasi ito, log 10 siya, base 10, log base 10 siya. Okay, kung makikita niyo dun sa website later on, log base 10 siya. Pero ito log base 2. Ang natural log kasi log base 10 siya. So hindi niyo siya makukuha agad ng log base 2. So kailangan i-ln niyo muna siya. Okay? So parang ln sa ano niyo, sa scientific calculator niyo. Pero wala. Wala. So sa scientific calculator niyo, isa-solve nyo muna yung para makuha nyo yung log 2, i-ln nyo muna siya, ln, tapos ito, isa-solve nyo to, okay, over ln2 para makuha nyo yung result nito. Okay, ito and then afterwards, i-multiply nyo siya rito. Okay, kung ima-manual nyo siya. So again, log 10 kasi to, log 2 ang hinahanap natin. Log base 2. Wala kasi nun. So, ang gagawin nyo, ln, hanapin nyo yung ln sa scientific calculator nyo. ln, tapos kukunin nyo yung 3/5, tapos kung anong result nun, over ln of 2, para makuha nyo yung log 2. So, pagka naka-log 2 na siya, nakuha nyo na yung result nito, then that's the time you multiply it dito sa 3/5 and so on. Minus, and then alam niyo naman na yan, pag minus siya, tapos this one, perform this one, minus, magiging minus siya, and then from there, ipaparenthesis niyo siya, and then if you multiply, magiging positive siya, so parang negative point something, multiply by negative 1 point something, ganun. Makakakuha kayo ng positive, then from there, mag-a-add na kayo, and so on. This one. Okay, then you will be able to get this one, 69.693 bits. Anyway, like I've said, I'm going to give the Excel file of this one later on. So there are steps that you will follow. Okay, as an example, let me just share and so on. And splitting. No, you'll be doing the splitting, no, on that part. No. Now, I'll stop from here, no, kasi medyo ano na siya, uh, more on the activity na siya, no.